Witajcie pri Gisela Jana.net API review. And Adam's probably wincing at my bad Polish, but I tried. All right. We only have a few red items today, and then a whole lot of items that we'll see if we get past the red items. But let's just jump right in. Add a persisted assembly builder type, issue 97015.
Yeah. So we have added a new persistent assembly builder in preview 1, and as a next step, we were about to adding an entry point API for the assembly builder. And while we're discussing the set entry point, there were questions raised for adding the overload that sets P file kind option. And also another customer also asked, what about supporting adding the options for setting portable executable kinds and image file machine options that was available in .NET Framework. And well, I was initially planning to add a separate API for all that options that used to set in .NET Framework, and also setting all other options that is available in P Builder. And but there is so many options. If you scroll a little bit up, and there is so many options we could set in using the P header builder and manage P builder, that all are, most of them has default values, so that you don't have to set everything if you're not sure or if you're not needed to set. And just adding options for all these, adding another API for supporting all these options is just doesn't make sense. So instead, we prefer to adding new API that returns the metadata we have produced with the reflection image APIs so far. But metadata builder is not accessible from within the core lib. Therefore, we couldn't add it into the assembly builder type itself. And therefore, we want to make the persistent assembly builder type public, and that derives from assembly builder, and move all new APIs we added in the assembly builder to this type, and remove those from assembly builder. Plus, we want to add the main new method that would use to generate the metadata, that would return metadata builder and the IL stream, field data that would need to produce the PE file. And the example API use shows how all this work together.
So
this also will be useful for. Go ahead.
Yeah, I was waiting on Emo to jump in because he mentioned yesterday some issues with not liking a disalignment from .NET Framework, but were these public save present in .NET Framework? I'm not seeing them on what I'll still call MSDN.
There should be.
The string overload is.
Oh, because I'm viewing Net8, not Framework. Because we made the doc site hard.
So yeah, I think I mentioned this before, but I think as a general principle, if we bring .NET Framework functionality to core, we should keep it binary compatible, because that means if people consume .NET Framework binaries through the compat.shim, then that functionality just lines up and works. It's always sad when we have the same feature on core, but then just because we chose to have a different shape, they no longer work, right?
I agree with that. At the same time, we have said that, like we are done with adding .NET Framework compatibility, right? And we will look at everything as bit kind of clean slate. So,
I mean, to some extent, I think the question is like, where do we draw the line? But I think what we basically try to avoid is bringing back huge functionality gaps that we have. Like, I don't know what would come to mind here, but let's say the rest of WCF, right? We said we're not going to do this anymore, right? But I think for things like this, where we're talking about a couple methods, the question is the shape difference worth it to us, right? And that's clearly a judgment call. There's not a, clear-cut line, I guess.
but as it exists, right, that the reflection emit that saves to disk won't work in binary compatible way because of the main entry point. We didn't make that compatible, right? Basically, in .NET Framework, there is a new enum value that you need to specify. We have different entry point that doesn't depend on the new enum value in .NET Core. So that whole scenario is kind of, lost cause. Sure, we can go and kind of add all the wrappers in all the right places to make things work, but it's kind of, why bother,
I mean, I don't remember, like, what's the difference in the entry point that we chose?
Well, in .NET Framework, if you want to create one of these persisted assembly builders, you specify assembly builder something dot save enum value when creating it. But in .NET Core shape of that API, we chose to introduce a different entry point that doesn't depend on the enum value, but that takes extra argument that points to the core assembly. So that's a kind of important feature in the .NET Core version, that the API allows you to target arbitrarily different runtime. In .NET Framework, you can only ever target the runtime you are running on.
I vaguely remember now. And that has shipped, or is that new for 9 already?
All these APIs are new for 9. But I think we would definitely want to have that new entry point that takes the extra core assembly in .NET Core version. So whether we do all these like shimming for .NET Framework compat, that one is kind of secondary to me.
Get out of the way, window.
It's extra work basically.
Misclick.
Something that Steven pointed out in the discussion is that what's nice about this persistent assembly builder type, that it's the save method on it actually works. When we had the abstract save method on assembly builder, it may work or may not work depending on how you have created it. So the advantage of moving the save method into the inherited type is that there's clarity about, yes, it's persisted, so the save method works. So.
Do you know how people use Assembly Builder in practice? Like, are they going to pass one into a function? Because if the only difference we have from .NET Framework right now is you had to construct it differently, that's a single pound if you're multi-targeted. But once we start changing that, now when they're done, that they need to call save on this different type, then now they have a much more complicated set of multi-targeting code if they have multi-targeting code. So that's where it comes down to if the save would be in the same function that's going to create it 9/9 of the time, then I probably care a lot less.
No, I would expect to be the case in like many cases. Because of the kind of the typical way you use this API, you create the builder, you pass it to your compiler infrastructure that will dump all the stuff into it, and once that thing returns and you have everything in it, you save it. So I would expect the point where it's created and the point where it's saved to be same layer or maybe same method.
Fair enough.
Yeah, I mean, if you think of IL emitting, I mean, it's usually pretty targeted, right? The thing that gets passed around a lot is the IL emitter, because that's where you party on. But the thing that basically creates the outer components is usually within one method body. Yeah, that's what I've seen as well. But I think to me, I care much less about, like, so if we get 99% there, but then the factory to create it is different, then to me that I don't care anymore, because it's like the point of compat would be you take an existing .NET Framework binary and have it work, right? So if you change the core method that creates one of those, well, then you're still busted, because usually the layer that would do both is in the same assembly, so the assembly still doesn't work, right? I mean, yes, for multi-targeting, it's still nice if things are somewhat similar, so there's clearly a sliding scale of more is more. But I think the question then becomes, how do we, how much do we care? Because I mean, at that point, if we give up on binary compat, I'd rather have a design that we stand behind. Because I think people multi-targeting between the two, that's a much smaller set of people. So remind me for the new API that takes the core assembly, what would we expect the caller to pass in? Basically, we would not expect them to pass in type of object.assembly, right? Which is basically private core lib, right? We would expect them to pass in, I don't know, basically some public reference assembly, right?
Yeah, if they are building kind of proper compiler that targets arbitrary, that runs on one version of the runtime and targets a different version of the runtime, like most compilers do, then we would expect them to pass in something they create using the system reflection metadata old context.
That's kind of my other question. So like, then all of reflection mid would work with these, I don't know what we would call them, but pure metadata APIs that don't allow you to do reflection invoke. And
Yes,
that would still work.
That's the expectation. That's more like, I'm not sure how much we are testing it, but it's expected to work.
So then let me turn this around, then. So it completely makes sense to say, if you're building for core, or if you're building on core, we want to avoid a situation where someone uses these APIs and basically creates an assembly that, by happenstance, that we can't run on anymore because we never tested to run against implementation assemblies, right? So we want to make that as easy as possible. So in that sense, the new API shape makes sense. Could we then also say we still try to make it binary compatible with full framework? Is that kind of, can I think of this as an orthogonal concept where we could, for example, have the APIs in the implementation only, but don't actually have them in the reference assembly? Would that be workable?
Oh yeah, we can do it if we choose to. Yeah, but I agree with you. It's basically like orthogonal extra work. Basically, it's like shimming. It's kind of similar to how we have MS collib DLL that just forwards to all the random places. It's kind of similar concept that we add basically an entry point that does whatever it did in .NET Framework. And
yeah. Yeah, that seems desirable. So like I was recently talking to a first party team again that tries to move to core, and reflection with APIs was one of the things that showed up again. So I don't know enough about the inheritance hierarchy, but if we had to shim it, would that still work with this inheritance model?
Yeah, but like we just reflection invoke actual entry point. Right?
I guess. Yep. Yeah, if that's the case, I don't have concerns about the new shape. I think that's fine. I just want to avoid a situation where we corner ourselves and then can't make it work.
Right, so we're basically looking at something like that, assuming that the save and create live in the same function. But if do stuff is what's calling save, then it gets more complicated because it needs to if net 9 or greater as or hardcast to persistent assembly builder so it can even see the save method.
Right.
And this is presuming you're targeting full framework or 9 and greater and like skipping over the previous versions of .NET Core.
Yeah.
Yeah.
Because I think we had no save support up until very recently.
Mm-hmm. And sorry if I missed this earlier, but since I'm talking, there's a lot of talk of the set entry point method. Is that part of this API proposal? Is that going to be on the persistent assembly builder?
That is covered in the usage example.
So like I look at the set entry point method as another one of those things that we can shim. Basically this API shape. So the way the emitting of P file works, or .NET P file works, it's like you create these like metadata blobs, and you create a blob with the IL, and then you wrap it in the envelope, and the envelope can have like all sorts of flags on it. It has the entry point, it has like stack size, if that might be important if you are running on Windows. It has like several dozens kind of things that you can customize on it. One of the things also is like it has a bit on it whether it should be like GUI up on Windows or not. So we didn't want to expose all these like fine-grained things as individual APIs. So that's the idea behind the generate metadata. It's basically like if somebody wants to set any of these bits in the envelope, they just call generate metadata, get the blobs, and they wrap it into whatever custom envelope they want, right? So this is kind of the universal API shape that like allows people to do everything. If we care enough, we can create like special properties, special methods for setting, frequently used things. This API shape doesn't preclude that.
I completely don't remember these APIs. So basically the metadata builder, PE header builder, and manage P builder, they're all part of the emit APIs that we put in system reflection metadata already, right? Or
Right.
the writer APIs. They're the low-level writer APIs. They're the equivalent of the reader APIs we have. And then they are not part of reflection emit then. So I guess the what you guys provide is basically up to the. Oh, I see what you're saying. So basically save is the easy case, and if you want more control, then that's when you use generate the metadata one where you use low level metadata APIs. Got it.
Yeah.
So saves basically only good for a DLL.
Yeah, it's for DLL, kind of everything default in the envelope, right? So
Got it. I mean, that makes sense to me.
right, somebody mentioned the set entry point earlier. If we think that set entry point is like common enough, and it's likely that people out there might be writing compilers that just set the entry point and use everything else as default from the envelope. We can add the set entry point too, but it's kind of, we can do it anytime.
Okay, and then chat asks, is there a reason we don't have save async?
Well, all this is compute bound, like thing, right? So,
Well, I mean, right up until you hit save and you start pushing stuff into a stream.
oh, okay. It would just make the implementation like much more complicated, and slower.
I mean, you have the workaround that you show in the entry point, which is you create your own file stream and serialize the blob builder or something. You can use async APIs for that.
You're assuming that PE blob has write content to async. So
I am assuming that. You're right, and it probably doesn't.
Yeah,
you
really
want to do
cared,
this
you
in
would-
a web request.
You could do it in a memory stream and then asynchronously write that, right? If you really cared enough.
That's true.
Yeah, I would question the scenarios where someone is saving this to something other than either memory or disk, local disk, at which point async kind of isn't a big deal. If you were saving it across the world to a remote file share, and you were doing this on a hot path or some scalable thing, if you have a web server that's somehow, per request generating assemblies and saving them, then okay. I wouldn't mind just starting with the synchronous save and being done with it. We didn't have an async version for .NET Framework, right?
No, we never had. And I think even those in APIs, I don't think have async either. I think they have emit and they take a stream and then.
Yeah, I wouldn't object to an async one. I just don't think there's a strong need for it. Until we see that, I think it'd be fine to leave it out.
And also, the async is basically like a perf optimization, right? And when you look at memory consumption of this whole reflection emit, universe, like the actual final binary is like, small fraction of your total kind of allocation footprint, right? So if you are, say, producing 100K binary, you probably need to allocate several megabytes of these like reflection emit, builders. So saving it to memory stream doesn't kind of add significantly to your total overhead.
Yeah, it sounds like it might reduce it if the write to the stream is really slow. If you could, well, yeah, unroot the whole assembly builder.
okay. Anybody have any reason to not just hit approved? Sold.
Thank you.
Thank you. All right. Type name parser 97566.
Yeah, so over the years we have created a few internal type name parsers, and none of them were good for parsing from untrusted input. So we would like to put an end to that and have a single parser that is capable of doing all of that we need. The main concept that we need to understand before discussing the APIs is the complexity. This is something that Levi has introduced. So since we are parsing from untrusted input, the input can be anything. So imagine a list of int, blah, blah, blah. And as of today, providing such an input gives you Stack Overflow, for example, for type.getType by name. So we have this concept of complexity. Jeremy, could you scroll a little bit up? Yeah, here. So to tell the long story short, it represents the total amount of work that needs to be performed. You can think of it as of the number of type name instances that would be created if we were about to deconstruct the whole name. So int has a complexity of 1, but an array of ints has a complexity of 2, but an array of pointers to integers has a complexity of 3. So this is one thing where we don't have a counterpart in reflection APIs. And the parser is supposed to have 2 modes. One, the default, where it's parsing everything that is ECMA compliant. So whatever ECMA allows for, we are going to allow for it as well. This is, for example, will be used by type.getType APIs. And other is strict, where we provide a set of opinionated rules on top of that. Just to give you some examples, we won't allow for path characters in assembly names because people could do something like // my hacky folder / my mscorelib.dll in the type name. So these are the concepts that I wanted to introduce before discussing the API. Levi, were you able to get back?
Yes, hello.
Awesome.
I'm listening. I'm looking forward to this.
Awesome. So first of all, namespace, system reflection metadata. We have an ask from our first-party customers to expose this parser in an OOP package that is going to target.NET Standard, because some of them are still on full .NET framework. They won't be moving in the near future. They plan to do it in a few years from now. And they need to be more safe by having the possibility to parse such names, for example, in binders for binary formatter. So that's where the namespace comes from. And we have a type name, which represents the parsed name. Most of the APIs, the names are exactly like from the type API in reflection. So we have name, we have full name, we have assembly qualified name. On top of that, we have few properties like is RI, is constructed generic type, is elemental type, is nested type, is CZRI type, and is variable bound RI type. We have 2 properties that are currently not consistent with type APIs. It's the isManagePointer type, where in reflection we have isByref, and it's isUnmanagedPointer type, where in reflection we have just isPointer. So I'm free to changing these names. I just wanted to hear more opinions because so far Jan didn't like the new names. However, Levi had them used in the previous in his prototype that I have used. So I have, 1-to-1. So I wanted to hear more thoughts. Jan?
Like the number of APIs that are not aligned with reflection, it's more of them. Like is elemental type doesn't exist in reflection emit. It's called has element or has element type in reflection. And like I think there are a few other ones. I didn't go through it one by one, but it's more than that.
Yeah,
Yes,
and
but-
I can give some context, by the way, on why these names were chosen. It was it was just because it was following the ECMA terminology. But you know, Adam, given the target audience that is expected to use these APIs, one might be able to make a colorable argument that like you should try following the more typical naming rather than something that exactly matches ECMA. But just throwing that out there. I interrupted you. Sorry. Go ahead.
Yeah, so I don't have strong opinions about these names. What was important for me was to switch Mono, CLR, and native AOT to start using them, and I was able to do that. So I have battle tested this API. So I'm free to renaming the properties. I'm totally open to that. I just don't have strong opinion here. So we could have isByref and isPointer.
So
And all
what
the
would
other
the
ones,
argument
right?
be of changing any of them off of what Reflection already has? Because having a different name increases knowledge burden, and the only way that I would see that we would make the names friendlier here is if the people who use this were never expected to otherwise interact with Reflection, which I don't think is the case. So what's the argument for changing them?
Yeah, but on the other hand, I think that property like isByref, it's not really self-describing. So not few people know what is Byref, but everybody knows what is managed reference, managed pointer type. Sorry. So I thought of them as just more descriptive and more easy to understand. However, on the other hand, I was unable to provide more user-friendly name for a property that says that it's a single-dimensional zero-indexed array. So this is why we have is the array type.
Yeah, I think I think those of us that were in the follow the ECMA naming convention camp like have very weakly held opinions on that. If there is a consistency benefit to matching the existing Reflection terminology, like I would absolutely not be opposed to that.
Sorry, so is managed pointer type the ECMA name?
It is the ECMA name, correct?
Okay.
And this was intended to be an ECMA
So
parser.
So it's not that we're making the names friendlier, it's we have two different standards saying what the name is. ECMA says this, and 20 years of .NET say it's this.
Yeah. But given like you said, the intent is to determine if the intent is to mirror something that exists in Reflection, and probably at some point after you make a safety determination to convert back and forth between the two, then at that point maybe there is a very good argument for saying just use the same terminology that people have been used to for 2 decades.
Yeah, I mean, if it's actually one-to-one with like the type, properties, it seems natural to use those.
Yeah.
Like with is managed pointer type, like is that include like byref stuff, or is it like literally? Yeah, I guess I'll look at is byref. I'll read the documentation for that.
Actually, Jan, I think you would probably be the authority on that. Is byref is literally a managed pointer, correct?
Yeah, and there are like for is byref in particular, there are like 3 different names that are frequently used, like is byref, is by reference, kind of expand the abbreviation, and it's managed pointer. I think the managed pointer is the least frequently used one. If you look at the existing system reflection metadata, it has by reference, so it's like all over the place. So I think just saying stick with the existing reflection system.type naming would make most sense to me. But
I could buy that argument.
Yeah, and to me a little bit of it is what domain do we think the people are coming from? I think people are way more likely to come from system.reflection than they are to come from the ECMA spec, because to my knowledge, it's a write-only specification. Like, I don't know anybody who reads it, other than maybe
That's
Mono
fair.
when they wrote Mono, but now we've absorbed them, so no one reads it.
Adam reads it.
I was forced to read it.
No, that's fair. Those are all very fair points.
So let's stick with the reflection names.
Okay.
Yeah, like one more time, the containing type is also misaligned with reflection. It's called element type in reflection.
But is element type, doesn't it also describe the array element type?
Yeah, arrays are, arrays. The type of the array element is element type.
Yeah. So
That's how the
yeah. So here this containing type, it describes only the containing type that contains the nested type that we are currently parsing.
So containing
Oh,
versus
okay.
contained, which contained would be the element type if you called something like that.
Well, containing type's about nested types, not arrays, right?
Oh,
Right.
I see the comment
Yeah,
now
it's
with
the-
the plus symbol.
Yeah.
okay. I thought it's the element type. And anyway, I don't think there's containing type in reflection. It's called nested, or is there?
I'm looking through the APIs and I don't see one actually.
Do you just have to infer it from popping off the plus?
I'm pretty sure there must be a way to get to the containing type in reflection. It would be
Oh,
weird.
declaring type, I believe, is what it is. Because the nested type is a child of the declaring type, correct?
That's right. Yeah, it comes from member
Yeah.
info.
Okay. Yeah, get the type that declares the current nested type. Okay, so it's called the declaring type.
Yeah, I think it makes sense to align there too. I think that's even probably more clear than containing type. But they're both kind of ambiguous, but we've already used declaring type.
Sure.
The other thought I have about the opinionated behaviors, I'm wondering how much of that opinionated behaviors, like disavowing certain characters, should be in this type versus in the, whoever is using the whoever is using the
If you scroll down, there are the parse methods. Like there is of course the total complexity that returns the integer, and we have two parse methods: one that parses and throws if there is a problem, and the try parse. And both of them accept an optional instance of type name parse options, where we can specify whether we would like to allow for fully qualified name, what's the max total complexity, and whether we want the strict mode or not. So Jan is talking about this strict mode property that is, we can see on the bottom the comment that explains it, but yeah, now we can see the property as well, strict validation.
Right.
So one interesting behavior there. Oh, go ahead, Jeremy.
I was going to say, I'm going to straight up object to strict, because strict means follow the spec, and you're opinionated beyond the spec. So strict is the wrong word here. But
yeah,
move on. We'll
it's
circle back.
more it's more like a it's not necessarily strict as much as it is like forbidding things that we believe are indicative of somebody trying to do something that's potentially hostile. Adam had mentioned earlier, like including .. and other characters in the assembly name. One of the other things that strict did, at least in the prototype that we had created, is it limited what cultures could be listed for the culture property in the assembly. It made sure that it used a different way to parse version than using version.parse and so on. Like it forbade a bunch of nonsense which would indicate somebody trying to mess with the system. Now, you could potentially argue that, like, okay, some of that validation could really go into a different type, right? Like if we give you, if this type just represents what the input was, and then it's up to another layer to kind of validate it and apply policy, that would normally be the right way to do this. However, for things like culture, for instance, we need to know what cultures to allow or reject before we even create the type name instance. Because if we allow something that's improper to come through, like you have allowed an attack to take place before the type name was even presented to the caller for validation. So that's one of the things that we kind of need to consider here.
Yeah, I would be fine, say for the culture thing, I would be fine with having a specific flag that says, don't resolve culture. And, that makes sense. By the way, like, I think in the API shape, we might want to have a way how to get the unresolved culture too for that mode. But, having kind of this grab back of like behaviors, that doesn't sound right to me.
Yeah, and for other people on this call who probably haven't like seen the full details here, things like culture info.get culture info that takes a string, like if you pass that hostile input, there are ways to attack that. So one of the things that this tries to do is it tries to say, let me look at the incoming string before I pass it to get culture info and cut out things that are hostile.
So maybe you discussed this in the beginning and I just missed it, but like so let's say I do all of this, right? So like I basically create the type name. So what am I supposed to do as the caller then? Am I supposed to reject basically when the complexity is too high, or how do I use it safely? Like what constitutes safe use, I guess?
Adam, you want to take that or do you want me to?
I can take it. So if you scroll down, there is a sample implementation of a type of binder, which is used, for example, in formatters, the binary formatter as well. So first of all, you have to specify some max complexity. I think we'll end up with a default of 10 because otherwise you are vulnerable to people providing input that will give you Stack Overflow. And a great example is list of lists. Currently,
Right.
if you create such a list where you have like more than 1,000, you get Stack Overflow and the process dies.
Right.
So to be safe, the first thing is to specify the complexity. We will, of course, provide the default, so you don't even have to do that. And if you want to be extra safe, you can turn on this opinionated mode.
Which is the strict one that you talked about earlier, right?
Yes, but I didn't use this name because Jeremy doesn't like it.
Yeah,
Right,
but I think the idea is, okay, you limit basically the characters that you consider safe, and you limit the number of logically nested types, basically, right, in terms of generics or other things. So, but then after that, like, it seems like looking at the sample code here, like the expectation is that I more or less have to walk the type name structure now myself, with you're basically getting the nested types out of it, getting the arrays out of it, getting the generic instantiations out of it, and then recursively call effectively type.getType given the name, right?
Yes, but ideally, in the binder, you would have like a dictionary of names to types, and you would never call type.getType. You would be just checking if something of this name is present in the dictionary, because this is on the allow list. There is a link where I have provided like a full implementation because we really don't want the users to use type.getType in these binders.
So that one I can understand because type.getType I think will also do the expansion of the whatever the encoding is, right, with like brackets and other stuff, right? So, but do we really want people to write the code that basically does what you have here on screen, where you say like if parse.isArray, if parse.is constructed generate? Because it seems like there is only one correct answer to do this. Like it almost seems like what you want is an API where you can say, here's the number of safe types, constructing arrays over them is safe, and then you just take the type name instance and give me back a type, however you want to do this, right?
This is an excellent question, and one of my follow-ups will be to provide a proposal for binder where the users just provide an allow list, which is a list of types, and we do that for them. But for some super users, for example, including CLR itself, that is using this, that will use this API, we need this information.
But by the way, kind of extending on what Adam said, we already have a prototype of a binder that uses an allow list, as Adam had described. And we know that the shape that Adam is proposing here works for that scenario because we have already deployed that internally to a few first-party services, and it is working successfully.
So to be clear, like I'm not objecting to this low-level API. I guess what I'm objecting to is taking a scenario that is currently a one-liner, say this is not the safe way to do it, and then the safe way to do it is go read the ECMA script, figure out what types are effectively, or understand the shapes the types can be in, and write a switch statement yourself, because that seems like a recipe for just another set of issues that are now all in user code rather than in the runtime code, right? So if we basically said this is just a stepping stone towards giving us a more high-level API that is maybe not a one-liner, but it's basically akin to the entry level that you have here, where you say type name dot parse with some defaults, and then you pass that to another API that takes, let's say, a dictionary of allow types or something, I'd be okay with that, because that seems like a somewhat, very logical transition to, yes, limit the types you accept, tell us which types you accept, and then we do the parsing for you.
Yes, and that lookup mechanism, like I said, is already deployed to a few first-party services, but it needs a representation of the data. And the representation of the data is the thing that Adam is presenting right now.
Yeah.
Right. But if everyone who uses this needs to write the highlighted lines of code,
no.
Then we've made a mistake, and this should be, there should be on this thing a, public type resolve, and then either dictionary of string to type element types, or whatever you want to call it, or a func of string to type. The dictionary is probably better because it tells you that you should use a pre-canned list, but like if people have to come and just like copy and paste this every time they want to do it, we're missing something.
No, the code that you have on the screen right now is the code that would be in the resolver itself, and the idea is there would be a shared set of resolvers or a shared set of allow list mechanisms that people could use within their applications more easily. But the logic that you're looking at here is
where's
proof that such a mechanism could be written.
Who's supposed to write that?
That could be written by us, could be written by partner teams. Like I said,
right. So we're missing something.
Already some floating around internally.
No, so we're missing something. If your proposal ends here with someone can write this code, that means everyone must write this code. That means we're missing something and the proposal's not complete.
Jeremy, but the reason why I haven't introduced the binder to this proposal is that because we want to remove binary from matter from PCL and move it to an OOP package that is not supported.
Sure.
So I kind of didn't want to introduce a new type just to remove it after it. So,
but again,
it was the first step.
This looks like a simple piece of logic that can be written as a utility method in terms of a dictionary that you pass in on this existing type. If somebody wants simply this level of composition internally, it seems like this belongs on this type and not somewhere else.
Well, this type, right, it's like in system reflection metadata. System reflection metadata has like no reference to system.type in its public surface, right? This is basically just parsing the format that's specified by the ECMA spec, right?
Yeah, I think so. Basically, what you're proposing here is just a low-level parser. So we're not making the claim that this is addressing the type.getType being unsafe. It's just half of that, which is basically a parser that is resilient to, let's say, Stack Overflow text because it has an intrinsic limiter, basically. And then the next thing on top of it would be some sort of higher level API that would I don't know what it would look like, but it would basically presumably take a type name and a dictionary or something like that.
Because looking at the amount of code here that someone would need to do to use this right, I expect if we ship this, 99% of calls are going to that involve this are going to call try-parse, and if it succeeds, call type.getType of type name.assembly qualified name.
Or
right. Well, at that point, they would literally just call type.getType, but yeah.
Well, they got the complexity filter, and it's like, yep, it wasn't complex. It wasn't complex enough to make the try fail, so call type.getType. I'm just This is It's doing what you said you wanted to do. I think it's maybe doing more harm than good if we add it.
Are you concerned that that today we're only talking about the very lowest level of a multi-layered system?
Right, and that's why I'm asking where, like, if this other thing is, once we get this in, we expect to be bringing this as public API in another month or two, then, like, I understand your layering now. But assuming that this is the end of the proposal, we're missing something.
It's the end of proposal for just parsing the names, and on top of that, we will provide utilities like a binder with an allow list, and I will be porting some open source NuGet packages from. I'll be removing the dependency on binary formatting, and I will make sure that we have solution to every scenario, and that it's easy to move off binary formatter because it was very easy to use it, and I want to make sure that it's also easy to move off.
So that one I agree with, because I think fundamentally what you're trying to replace here is type.getName, or type.getType given a string, right? And I think, so that's a one-liner today. So like, I think if you try to do that and you answer what you have on screen, we failed because it's not going to succeed, right?
No,
so that's why I'm saying if we say
everyone
this is
keeps
just the
saying
data.
that, but like, I trust Adam when he says that we don't expect anyone to type this. Like, Adam has said that multiple times, and people seem not to be internalizing that.
But that's why I asked where it was going to be.
We had the proposal.
Yeah. And you said we could write it, or someone else could write it.
So
the could is what I have objection to.
We have already done it.
But where's it going to live?
CLR has such a parser. Some of the native IoT tooling is depending on the one of internal parsers, and Lawson is having their own parser as well.
Or are those implementation details?
But they need this level of information.
No. But
Jeremy, like if you want an honest answer, like this work is already done. It's already security reviewed. It's already deployed within Microsoft first-party code. The reason it hasn't been brought here is because nobody on our team wants to own it.
Right, but
the work is already done.
But again, we're back to.
But I think I think if we start differently, right? If we just say there's a bunch of parties today that parse type names, like Rosin, for example, and this is just the answer to that, I'm completely on board. I think it's a reasonable API. It just gives you data. There's nothing wrong with that, right? I think the problem is the proposal kind of started to say type.getType is insecure or unsafe. Here's a safer way of doing it. But then the problem is that it's not a one-liner or even like a four-liner replacement. It's more like, well, we give you all the data. Now it's up to you to do it correctly. That seems like this is only half the story, right? So if we are basically saying, all right, this proposal is only half the story. It's the low-level reader for it that we can still use in other places. The other half is still coming. I'm fine with that. I think there's nothing wrong with that. I think the API shape is actually pretty good for that.
Right. So my concern is you say we've already written it, but if it's simply written as an implementation detail of the binary formatter extraction, that means that somebody else who has their own reason they're calling type.getType, they can't make use of that. So that's why I want to know, is it public? And if it's public, where's it going to live?
I think that's the second half that hasn't been done.
It's going to live in system reflection metadata.
Okay.
And
That is an answer.
The
I can
initial
accept.
implementation was working only for the input from binary formatter, but I have made sure that it works for all of the different flavors we have invented in CLR. So it just
So by flavors, you mean the way we kind of represent constructed types?
So there is no specification for what a type name can be. So I kind of had to reverse engineer it.
I see. And so then I guess our answer is if you want to parse a type name without resolving anything, just literally getting this type name API is the answer to that. Is that a fair statement?
That's the first statement.
And then what I would suggest is then let's focus on just that part of it, and then let's say the solution to don't use type.getType is then addressed with a later proposal that gives us some sort of high-level API, or not, right? But I think it's kind of like separate from this proposal. I guess what I'm trying to say.
It's separate.
I mean, unless, like, that's what I'm trying to understand the use case. Like, you know, if this is only for like binary formatter kind of scenarios, like, could we have a higher level API only that like literally takes the allowed list of APIs and maybe a complexity or something along those lines? And like, that's kind of a lower commitment than like redoing reflection type APIs on type name.
So the answer to that is no. The reason being that this is used for more than binary formatter. It's also used for things like Newtonsoft and other places where people are currently using type.getType and need to move off of it. The second is that the thing that's not being shown here is that the original prototype also had a visitor pattern for inspecting and rewriting these. Reason being that the allow list isn't necessarily always complete. Things need to be inspected and rewritten. For example, one of the things that one of our partners does in their custom binder is they actually say, well, the incoming type names are foo.bar.baz, but I actually want to resolve that to types quux.bar.baz or whatever. So they do namespace and type name rewrites before they even resolve things against their allow list. They also do things like change public key tokens because they actually changed their strong name signing key between version A and version B. Right. They do a bunch of fix-ups before they even check the allow list. And they were doing those through regexes, and the regexes were complex enough that it was allowing a bunch of garbage to come through the system, and it was causing security incidents in their services. That's one of the reasons that this exists, because this is the officially sanctioned way to do this parsing and to give you the representation of it that you can now decompose, modify whatever you need to modify, put it all back together, and now you have a unified view of the final type that you can compare against your allow list.
Sorry, what type of transformations were they doing?
They were,
for what reason?
They were
So imagine something that just like type forwarding, right? Let's say you rename the namespace, but you still get the payload with the old namespace. You want to replace that. But now imagine you have something like a dictionary or like a generic type. So now you have the namespace occurring in multiple places. You have to regex max this with everything else, right? So that's very quickly getting out of hand, right? If you don't exactly understand the semantics. So I guess what I'm trying to get at is, I think we're all on the same page. So we need some sort of low-level API that does the parsing. Ideally, there's some higher-level API that gives you something, either a visitor or a binder or some other higher-level concepts that, given the type name, allows you to kind of walk the hierarchy and ultimately gives you an instance of system.type if you wanted to. And that's not tied to binary formatter. That's just a generic going from a type name, go to a type in a safe way, right? And do whatever transformations you need to do on those types. That's a secondary proposal, but still we want a low-level parsing API that centralizes all the parsing we currently have in one place and is not tied to system.type and lives in reflection metadata. And that's what this proposal is. Is that an accurate summary so far of what we said?
Yes, it is.
then I guess my question is, are we okay with the proposal as it is, or do we think anything needs to change? I think the only thing we have said so far was some minor tweaks to align it with reflection.
I would like to know like what these actually map to in reflection. I think for a lot of people it's obvious, but can you scroll down to the underlying type remarks? Like that one, for example, seems bizarre. So it's like, okay, with an array or like you know, array of arrays, it returns what's effectively the generic parameter, the inner array. But given a dictionary, instead of returning the generic parameters, it strips the generic parameters and then gives you an open generic. Like why?
Because to load the type, you actually need to. If you have like a good example is nullable, because it's also generic. So you don't want to load nullable of integers. You want to load the open generic of nullable and then make generic out of it by providing the integer parameter.
So what's the deal with the arrays? Because it's like not giving you the container type. It's giving you like the element type, it looks like.
Well, in reflection, it's different concepts, right? So the element type, there's only going to be one element type, right? If you have an array, clearly it's constructed over one other thing, right? And then there's the other thing, which is basically if it's a constructed generic, well, then it's a different thing.
It just seems different conceptually. One seems to be unwrapping, and the other seems to be like giving you the wrapper.
I think you're right. Underlying type might be confused with underlying system type, which could give the wrong impression.
Enough so that I already renamed it.
You had your hand up. Okay.
But yeah, I just wanted to say the same thing, that underlying type is a thing in reflection that means something completely different.
Mm-hmm.
So, you know, it kind of, you know, +1 to just, you know, use the same names as in reflection throughout the...
Right, so is this two different things from reflection that are being mushed into one?
It is.
Yeah, I think so. Yeah, like
it's
reflection
get element type, yeah.
Oh, so it is the same with reflection. So when you're standing on an instantiate generic, you get the underlying open generic?
In reflection, the API that you would use for that is get generic type definition.
Right.
And that will give you dictionary of T as opposed to dictionary of closed.
Gotcha.
Okay, so underlying type becomes element type because you want it to be a property instead of a method, and generic type definition? Again, because you want it as a property instead of a method?
Should we maybe just make those methods, Adam?
I'm fine with that, and I'm also fine with having two methods. That would be using the reflection naming. So we wouldn't putting two things in one thing and avoid the confusion.
One kind of weird thing is that get element type returns null for non-array, non-pointer types, and get generic type definition always returns non-null or throws. Which I guess maybe we would want to match that semantic.
I think it would be okay, you know, for these things to... I think it would be okay to change the throwing behaviors if we care. You know, it's basically just changing... The reflection is inconsistent in this regard, so if we just want to say, if you are asking for element type, the thing better have element type, I think that's fine, you know, fine deviation from kind of how reflection works. It also helps with nullable annotations because of, you know, underlying type can return null. So we say when you are calling it, you still need to check whether it returned null. Versus if it's throwing, you basically have to check upfront, and once you call it, you know it didn't return null, right? So
I would agree with that. That seems like a nicer model.
Sure.
So there would all be methods, right? Would we get element type, get generic type, I think, right?
Yeah. Well,
they would just say either it succeeds or it throws because you didn't check for his pointer or his array.
All right, so non-null returning.
Yeah, non-null returning and throw if you fuck it up.
Yep. And then is elemental type that's actually has element type, I think.
Yeah, I guess is elemental type is basically a way to say you are an array, or what does it mean? Or does it mean you're a primitive type like int, string?
You're primitive. You're something with complexity of 1. So you're not a pointer, not a reference, not an array, not a generic.
Okay, so this is not from system type. This is a new opinionated thing on this API.
Isn't that called a named type?
The first time I hear named type.
It's basically things that have a name, right? So nothing that has an asterisk or brackets or angle brackets or anything of that sort, right? So it's a thing that exists somewhere, right? You can resolve it and it points to an actual thing somewhere.
Yeah.
What we could do is we could say if is elemental type is supposed to represent something that has complexity 1, then maybe it would be more straightforward for somebody to look at the complexity property and say equals 1.
Yeah, I guess that's true too. Like, yeah, who cares about this thing? Only your counterpart, presumably, right?
It's basically, it means that when you're inspecting this, just stop. There's nothing further to inspect other than just the name in the assembly.
Ah.
Basically,
It's as
instead
low
of
as you can
checking
in the system.
all the other properties, you check this one and it says, yeah, this is the simple case, right? Is that the idea?
Yeah.
I like deleting the property a lot. And then like if this really is the equivalent of total complexity equals 1, like that's way more clear to me than whatever elemental means.
Yeah. Especially because there's get element type, which sounds like it's related to elemental type. So yeah, so really the question here is what parts of these are mapping to reflection and what parts of these are new, because this was thrown in with a bunch of things that are mapping to reflection but isn't. So now we get to go through them one by one because the presentation's not clear.
Yeah, so everything related to names is 1-to-1. Name, full name, and assembly qualified name. Then we have already agreed that we are going to rename the containing type to whatever the reflection is using. We have already agreed to change the names for pointers and references. So what I believe, reflection has is array, so it's fine. It's nested type.
I have a question about containing type before we move past it, because I actually put it in chat. But so I think that maps to declaring type in reflection,
Yes.
but declaring type is also the type parameter, which it looks like you could get out of the type name API if you call like get generic arguments or something. So would that also have a declaring type that would point to, in that case, like the generic class that had the type parameter? Like, will it actually map 1-to-1 to the reflection API? Or is it just like nested types?
I don't.
Just nested types.
Yeah, I don't think with this name that you could ever have a type name representing the generic type or the generic positional parameter.
I was wondering, so if you called like get generic arguments on open generic type name, you wouldn't, or like with a type name, you does it have to be like a closed type? Can you have like T's and stuff in there?
Oh, that's true. We do have get generic arguments. So presumably of dictionary of T, this is, well, okay, that's a bad one because it has, so dictionary of to key and to value, this will give you a type name that says just to key and to value. Right?
I don't think so, because you can't reference those, right? You cannot I don't think in this representation you can ever reference a generic parameter. You can only reference a generic argument.
Oh, right. There's, yeah. Okay, so this is, if you've specified dictionary of string to int, this will tell you string and int. but you can't talk
Correct.
about the unresolved generic.
You don't get t key t value. The best you can do
Okay.
is that the underlying generic type takes 2 arguments. That's the only thing you know.
Okay, then I think using the reflection thing is fine.
And the
So
generic arity only comes from the count of what we return from this?
I
That's correct.
think so, yeah. So that's, yeah, I mean, don't you need to have something like generic arity or something on this? Or is the, or I guess you're basically saying the caller, before you unwrap it, has to do that.
Or you could call get generic arguments dot length or something.
And you have the is constructed generic type property to check whether something is a generic. And
So,
then
but
you
if
typically-
so if you get a dictionary of int comma string and I call get generic type definition, so now I get the dictionary tick 2, how do I know it's tick 2 at that point? I basically have to remember it from before that I and there were 2 arguments.
Yeah.
So yes.
I guess that's fair.
I mean, it's accessible right now via. We're going to argue about this when we get down here, but get generic arguments has a length that you can read, so that will tell you the arity. Reflection has it as a generic arity property, though, right?
Oh no, I don't think there is any arity property in reflection.
Yep. Arity
I
does
mean,
not
Wasden
exist.
has done it. CCI has done it.
Right. Just system.type has no sequence of arity in its structure.
Oh,
so-
because in reflection it's a full object model, right? In reflection on the generic type, you can actually ask for the generic parameters, and you would get t key t value, right? Because it's not just a type name.
Right.
You actually stand on the definition of the thing at that point.
And it doesn't have like generic parameter count. You just have to call like get generic parameters and ask what its count is.
Yeah.
And also, I'm not sure whether using a backtick has to mean that it's a generic type. I think it's fine to have a type called non-generic backtick 1.
The backtick is a convention of just the Roslyn compiler. It's not semantic.
So ECMA is not prohibiting that. So we can.
If you want your
say
type
that
to not
it
work,
has an
then
arity of 1.
yeah, I guess that's fair.
Okay, so is elemental type was cut. This is biref. This is called is nested. This is sz with a capital Z array. This is pointer, and this is variable bound array. Again, I just took all
and
of
this
these
is
as the names
something
from
that
type.
we can discuss, because is variable bound array means that it's an array with a rank greater than 1, or a single dimension array which isn't 0 indexed.
So that's just is array and is not sz array.
Yes.
Yeah, I mean,
And the way to express
Type
that
thinks it's
is
useful.
to use asterisk between the brackets.
fun times.
I think we will need, even if we don't have an API for it, I think we will need terminology for something that has complexity 1, because once you start dealing with things like visitor patterns, allow lists, things like that, we're going to need to expose through public APIs some kind of name that is like ensure this thing has complexity 1, or visit only types if they have complexity 1, or something like that. They were called elemental in the prototype, but I agree it's a bad name. So we should just be mindful of the fact we do need to name it at some point,
I mean,
even if we don't have a property for it.
non-complex. It's not complex if the complexity is 1.
Simple.
Simple also works. It's just Does
It can be a
simple
very
mean
complex names that
lettable or
parses.
Yeah.
single register
Is it-
or?
Because I dropped in chat where the is elemental type property is actually used today in the prototype. And it's actually a very elegant solution that doesn't involve any of the ugly code people were concerned about earlier. But that said, like, we'll just need to figure out that name at some point.
And you think we need it in API
Simple
or just we need it for documentation?
It's because it will be exposed through a higher level API at some point in the future. If we, like I said, if we have a visitor pattern, for instance, the visitor pattern is going to need an overridable method that says visit. I called it elemental type, but we could call it visit simple type, for instance. We just need to agree on what that adjective is.
Why not just write a visitor that checks like the complexity and only does anything when it's one?
Because visitors generally, the visitor pattern normally has a base type that has a whole bunch of overridable methods, and you only override the ones that you care about. And we need a method to represent, like, I'm visiting something that has complexity 1, and we just need to figure out what the name of that method is.
I mean, you just have, it's like bool visit, right? And
Right.
the implementation would just say
have a lot of methods.
complexity equal 1.
Well,
Right, it doesn't
so,
have to be a lot of methods. Like, this is a low-level API, right? Like,
No, the things like visitor patterns tend to be very high-level APIs that write on top of low-level APIs, right? Because those are the things
not
that we want to
always.
expose. Well, if you look at like what Link does, for instance, like there is a visit expression method. I don't even know if it's virtual, to be honest. But they expect that you actually override the methods that are specialized for the things that you're visiting, not the overarching visit expression method. And this would do the same thing. Like we wouldn't want you to override the visit type name method just to do like if complexity equals 1, whatever. Like you should really only override the like I'm visiting something simple or elemental or whatever, because that's where you do your allow list check.
yeah, I'm surprised that you wouldn't just like, what's so wrong with the if complexity equals 1?
Because then you end
that's-
up with a really ugly code everyone in this chat was whining about earlier.
But no one's going to be writing a visitor, right? Like, hopefully not many people.
Oh, yes.
Like, they're going
Yes,
to be passing
people-
an allow list.
People write visitors. Like the visitor is how you do things like replace your public key or replace namespaces or something like that. Like people would be expected to write visitors in certain cases.
Okay, and like those people can do if complexity equals 1. Like the people calling like get type name most of the time today, right? Like they're gonna just pass in an allow list and call get type name and have
So-
a max complexity.
What I don't understand is, so like we just talk about the visitor here for a moment, right? So like, why do we have to discuss the visitor? Why is it relevant?
It's because there was a conversation earlier here about that people were dissatisfied with that Adam was only bringing the really low level type without
Right.
bringing higher level patterns. And I'm giving examples in chat and verbally right now about higher level patterns that people are already deploying today across first party services. So we know that these patterns work. And these patterns are assuming that certain medium level components like visitors exist, these patterns are actually really easy to write the right thing. Like provably write the right thing.
So I guess what I'm confused is like, so ignoring the visitor for a moment, like what design point does the visitor discussion change on this type? Is it just a Boolean property we are talking about still? Is simple type or is elemental type? Do we need to represent this here somehow to make the visitor work? Is that the argument?
I'm saying that if the reason that we got rid of the property is that we can't think of a good name and we think that people should just say if complexity equals 1, like that's all well and good for the low type API, but at some point we are going to run headfirst into that problem and we're going to have to solve it at some point. So
Right.
I want to make sure that we're not just kicking the can down the road.
So you're basically saying we need a named concept for that, so we can have a visit XXX method that makes
Yes.
sense to us.
And
All right.
and yes, and if we had a named concept for it, would we just bring the property back with the proper name?
I think that we could do that. I mean, as I said before, like, you know, there's other prior art we could look at. I think, you know, in Roslyn they're all called named types. I think that's the same thing that CCI has been doing. I'm not sure type def is the best way to call it, because, you know, it's a bit of a weird concept, because logically what you're referring here is a type ref, not a type def. But yeah, I guess it's either one would probably work.
Yeah, I mean, like, is a generic type definition, so is system collections generic list of T, is that complexity 1?
As long as the T has not been filled in, then yes.
Yeah, if it's the open generic, yes. I
Right,
guess.
so the open generic's 1, and then the specified generic is 1 plus the complexity of the GTA.
Correct.
Jared, you want to say something?
Jared had his hand up. Yeah.
Sorry, I came in a little late. The elemental type joke really got me. How can assembly qualified name be non-null, but get assembly name can be null? That doesn't make sense.
Because, so, you can have a type name that does not specify assembly name, and then full name is equal to assembly qualified name, because there is nothing, but you don't have the assembly name.
Okay.
So, for
I guess
example,
that-
system.int32, it's name, full name, and assembly qualified name is the same value, and you have no assembly name.
I think
Or-
the runtime actually supports that today, by the way. Like, I'm pretty sure you can have an assembly that's divorced, or a type that's divorced from any assembly. Maybe Jan or someone else can correct me
But
there.
yeah, like type get type will fill in the default assembly name. Has a set of defaults for assembly name if it's not specified.
No, sorry, I
It
don't
has
mean
a really
type.getType.
wacko default.
I mean, like, if you use type builder, for instance, like, I thought it was possible to create a type with that's completely disassociated with any assembly at all.
I don't think so. Like type builder, like when you are creating type builder, you need assembly builder to create it. So you know, you can create your own abstract types that are not named and that, you know, just inherit from system.type, but then it's like nothing to do with this.
Yeah, then you're
Sure.
making your own rules. No, I mean, my understanding is that type always has to live in an assembly. It's just a question whether when you refer to it, you may omit the assembly name if the default rules work for you.
Right. For type.getType, I think is defined in the calling assembly or mscorelib.
Yeah,
Yes,
which is
yes,
not at all
exactly.
wacky.
So,
Only
In
breaks
order
people
to-
like 90% of the time.
so in order to know if something is assembly qualified, I have to create an assembly name type instance.
So you would like to have an is or has assembly
Well,
name property?
so part of my compiler pedanticism here is that, like, one thing that we find that a mistake we constantly find people make is thinking that type names are unique, that fully qualified type names are unique, and that's wrong. Assembly qualified names are basically unique, but type names are in no way, shape, or form unique, and we duplicate them all over the BCL. And it's just, you get run at a higher level. And so I get a little antsy when you have type names which are fall in a little gray area where it's like, is this something that is actually unique, or is this something that's kind of unique? And when we're kind of mixing assembly qualification and non-assembly qualification, and particularly when there's no way to know which one did you do here, then it becomes a little sketch on, like, can I trust this? Like, there's no way to know, can I trust this to be unique without allocating an assembly name object and then basically recursing down the type and saying, are all of my generic arguments assembly qualified? Like, it's hard to know how strong of a name we have here.
Currently, the weird way of checking would be comparing full name versus assembly qualified name. But I agree that maybe we should expose this information in a more readable and approachable way.
But to be clear, like what you have on the screen right now, Jeremy, would only be for one of those type names, right? As soon as you have something constructed, you would have to check it all the way down, right? Because we would not do this ourselves up front, right?
Why not? You're constructing the names when you parse it. Why wouldn't you know if it's composed of assembly? Like it's not any more information. It's just like a bool. You can put you can have a byte and put two little bits in there. Like is it locally qualified or is it like deeply qualified?
Yeah,
I see. So you could have two properties. One basically indicates the current type name instance, and the other one would be everything below it as well.
Right.
I've not
So it's
seen a
fully
need for
qualified.
that. I've never seen a need for anything below it, to be honest. Like if you have, you never have list of int, for instance. You always have like list of system.int32, mscorelib. And the outermost list doesn't necessarily have to have an assembly qualification with it. When you call type.getType, as people said earlier, we'll look in mscorelib. So what will happen there is the outermost list does not have an assembly name, but when you call get generic arguments, the innermost system int32 will have an assembly name. That said, Adam, I remember the original prototype did not expose assembly name. It actually had a parallel concept, similar to how there's a parallel concept to type here. Can you kind of go over why you thought using assembly name would be the better thing to expose?
Yeah. So the problem with assembly name is, so first of all, it would be hard for me to find a good name for a type that it's an assembly name, but it's a different assembly name, because it's describing the same thing, like an assembly name. But the problem with assembly name type that we have as of today is that it's mutable. That's why I'm not exposing it via property, but I'm returning you a copy anytime you ask for it. And if I remember correctly, it also does not implement iEquitable.
Right. The thing that we were prototyping previously did implement iEquitable, so that you could compare them. But in practice, people are probably just going to care about the name and nothing else. So
yeah, and when I was porting monocular and native AOT to this new implementation, this method was very handy because actually everybody needed assembly name.
Okay.
Wait, did you say the assembly was mutable, like on the type name object, or are we talking about something else?
So the assembly name is a type that has mutable properties.
Oh. Sorry, what's mutable?
The assembly name.
Or the assembly name itself. I was still thinking type name. Okay, sorry. Thank you.
So you can set culture. You can set version.
Yeah, so what the prototype was returning was basically a wrapper around assembly name that made it immutable and added things like comparison. But cut out the middleman, basically, just return assembly name if like Adam said, that's what people need anyway.
Well, I mean, I was going to bring this up when we got a little lower because I think Jan mentioned that the layering of system reflection metadata is it doesn't talk about reflection, but this is now breaking that wall.
Well, not necessary. Assembly name is kind of exchange type. It's not attached to reflection, and I think there are already cases in system reflection metadata that return assembly name.
Okay.
It's like for the same reason that Jeremy mentioned. It's like ideally we would have like assembly name version 2 that's done right.
There are a few places that SRM does refer to system reflection. Like we grab things like I think like generic parameter flags from system reflection. So there's not
certain enums.
There's not a. It would be nice if there was a pure separation, but there's a little bit of bleed on some of the like core primitives.
Fair enough.
Yeah, so it's if possible, you keep good separation. If not,
Right. So, what I got out of Jared's point is that we should expose something like has assembly name. Or
At the
is
very minimum,
is
but it will
assembly
be-
qualified reference, but like, I don't know that I actually even like the long name there.
Well, I think there's two arguments, right? Like at the very minimum, locally for a given type name, you want to know whether there's an assembly name without having to call get assembly name, right?
Right.
And then I think the question that Jared has is like he wants to basically say, given a type name, are every type references in there qualified, right?
Right.
And we don't have that today.
But we could extend the parse option back with a flag that says, make sure that all of the type names provide assembly names.
Right.
So basically, once you do that, you get an output and you know that everything there has the assembly name.
Yeah.
Yeah, for
I
the
mean- Sorry, go ahead.
for the has assembly name, I think more useful property would be the get simple assembly name or get assembly simple name. So that's what you frequently need, and you can check whether the thing has assembly name by checking whether this thing is null or not null.
So a simple string
See-
property that we just cache.
Yeah.
So basically, it's the assembly. So it's basically the assembly name of like assembly name comma version equals blah. But as a string, is that the idea?
No, just the simple name, like just the, say system.collection without all that other garbage.
Ah,
Is that's what most people want, I think. At least when I've spoken with our first party partners, that's what they want.
I mean, considering that culture doesn't matter, public key token no longer matters, version generally doesn't matter.
Right. So out of
Yeah, I can see
this
that.
whole long thing, you want a property that returns that.
Yep.
Yeah.
Right. So if this would parse legally, then Jared's question would be, how does somebody know that the inner type is not qualified?
You call get generic arguments and then inspect it too.
Yep. But I think, to Jared's earlier point, I think the reason why it probably doesn't matter here is because you have to, like, in order for this to be useful, you have to walk it and resolve it anyways, right? So you have to figure out whether the types resolve. But I mean, it's not like the type is globally unique. There's just rules, you try get calling assembly first and then you try call it. So there's only two places you look. So it's not that you will not resolve due to ambiguity. You might not be able to resolve due to, well, the type name just doesn't exist.
Right, but this is in but you're asserting how resolution works in like reflection, versus this is system reflection metadata, which is the more generic ECMA. How do we deal with metadata?
I think that's fair. I think the question is, given logically, this is going to replace type.get type, right? Which gives a string, and I think the resolution rules for that would be probably those, which is basically get calling assembly followed by callib, and otherwise it fails. Like there's no semantics where you say, oh, try all loaded modules and party on those, right?
All right. So do we like the concept of just extracting mscorelib or system.private.corelib or whatever as simple assembly name, or do we want a better name? I worry that if we say simple here, and then when we pop back up to the naming of is elemental type, that if we have simple being in two different cases, that we're going to confuse people.
To me, this name right now is a little bit confusing.
I think I would make it assembly simple name, maybe.
Yeah.
I don't know.
I like the idea of putting simple infixed there.
And how about just calling it assembly name? And maybe providing another property, assembly full name. Just trying to do it.
Because right now
Given
you
that
have get assembly name as a method, and it could be get assembly full name, but it seems weird to me that if you'd have a property called assembly name that's not returning assembly name, but then have a method that does. So
Well, the problem is really the overloading of name, right? Because guess what? The thing is called an assembly name.
Name.
So
Yeah.
so it's the assembly name. Maybe that's
Because
what we should call it.
what I would honestly do is if we did want to say one of these concepts is going to be promoted above the other, I would probably just say here is the string that you can parse as an assembly name instance if you really care.
Yeah.
Because that way we can always give you a cached string, so that's free. And if you want to parse it into an assembly name, you're taking the allocation, but we would have allocated for you anyway, so whatever.
I think that's reasonable.
Okay, so
But isn't assembly name parsing also problematic potentially? Doesn't
Not
that
if it's
hit the
gotten
disk?
this far.
So if it's a string that came from the type name parser, it's basically safe.
Yeah, as long as it got into this type, it has passed whatever parsing options you've specified.
all right,
So that
so
means assembly name dot parse will never hit the disk.
I mean, it won't do anything that you disallowed during construction of this, yeah. So if you disallowed culture explosions during parsing, then assembly qualified name, or the assembly name, once you turn it into an assembly name object, could also allow culture explosion. But by default,
Sure.
hopefully the answer is no.
so do we feel that we need the Boolean version of complexity equal 1? I will point out we're down to 15 minutes remaining.
I don't think that we need it right now, but I don't see anything stopping us from adding it in the future if we believe so. For example, in the next iteration where I will be bringing more APIs.
Yeah. It's
Okay.
also slightly phrased wrongly. Like the question of whether we need a Boolean for complexity equals 0, the question is whether we need to name the concept of a thing that is neither of the above.
Sure. Okay, is everyone happy with total complexity? Since this is actually a new concept that we're introducing on this type.
Why total? Why not just complexity? Like, isn't it always the total?
I think it's going back to the list Grav 1 is complexity 1, but the name representing this is complexity 2, because it's 1 for the argument plus 1 for the type. So I think it's saying how complex are you from this point, as opposed to your local complexity value,
Right.
Which is always
which
one.
is always 1.
Yeah, so it just seems kind of like unnecessary. Like, complexity is always total in the sense that it's interesting, but I don't feel super strongly.
I would just call
So-
it complexity.
For the complexity, I understand that, like we want to limit the complexity for, to avoid like Stack Overflows. But is it actually useful when inspecting the types? Like when I pass the, some complex type name and, presumably I put a complexity cap on it and it succeeded, why would I still care about the complexity?
When you're visiting this, you need to know when it's safe to do the comparison against the allow list, for instance. And the allow list will probably only have things of complexity 1 inside them, or simple or elemental or whatever we want to call it. So you need to know that what you're looking at is something that can be compared against the allow list without you needing to further drill in. Like the alternative to that is you can literally check every single property, is array, is generic, type, is biref, on and on and on, and then say if none of these match, I must be complexity 1, until we go and add a new property in the future that you're not aware of, and now things break.
Yeah, but I know that problem with like checking everything else to figure out that it's the simple case. So I would argue that, like if there's no kind of use case for the total complexity, we should just invent a name for yes, this is the simple case.
And I can see an
but
argument for exposing the value, which is when you're trying to decide what your limit is, you test what you think your most complex type is and ask what its score is.
But it adds unnecessary overhead to the whole thing, right? It's like the total complexity needs to be stored, or it needs to be computed on demand every time we call it. I don't know, like it's.
No, I think Jeremy was saying statically. It's kind of what Jared is saying in chat right now, right? Write a tool, run it over the outputs of Roslyn runtime SDK and multiply by 2, right? The easiest would be to say you just call the parsing API and ask for the score. But I think the problem there is you don't get the input conveniently, right? You would have to construct them in a way that type name parsing does it. You can't just use reflection, go on the element type, and then throw that into the type name parser, right? So you would have to do some unnatural gymnastics. So I don't think it's going to be that useful in practice.
Yeah, well, I mean, because you could take an existing library, load every, walk through all the types, run their types through this parser, ask total complexity, and take max, or do that same thing but keep lowering the value until it throws, and then that would tell you the total complexity.
Is what you just said I don't think works. Like if you use reflection or Roslyn or any other metadata reader to basically parse your types, you don't get a string representation you can throw into typename.parse here, I think. Because that is this very specific serialized type representation, right? That's
assembly, like if you have a thing that returns list event asking the method info's return type .assembly qualified name is not parsable by this?
It
I don't
should
think
be.
so.
I think we should. I mean, honestly, so when we did things like this in Roslyn, like we had to, like when we did like stack depth guards, we had basically like that's the thing where we say, hey, if we've gone too far down the stack, we start checking, exceeded max stack, so we can fail gracefully instead of blowing the stack. And we said like, that's a non-trivial check. How far down do we go before we actually? How deep do we go before we even start making this check? Like, what's a natural level of like how nested can an expression be? We just wrote a tool, ran it over all the source code and Roslyn runtime. It just said, what's the maximum level of nesting we see in our own code? And we found that was something like 12, and actually something like 10. And we ended up setting our stack guards at like 20 or something. After like 20 levels of nesting, then we'll start doing stack guard checks. For things like this, like 10, like you're going to hit reasonable customer input would hit a 10 complexity level. Like it's just a couple, like a dictionary of dictionaries, like you're going to hit it. Like, so you probably need a higher one. And I would recommend just writing the tool, running it on the output, like just go to all the assemblies in the SDK, dump all the type names and signatures and just see like, what's a max that we do? Like our input should not be considered hostile. Maybe.
I write some pretty gnarly code.
Yeah, I mean, there are parts of Roslyn where we have like 12 generic parameters because I can't tell you why, but we do.
Like in fairness, though, I think the question isn't necessarily whether you have that level of nesting, right? The question is, do you have that level of nesting for things that you happen to effectively serialize, or but you persist the type name, right, in some interesting way? That's probably more rare.
I mean, tuple goes up to what, 15?
Yeah, but who the fuck does that?
I'm just like, there's a simple type in corelib that has a instantiated complexity score of 16.
No, I mean, I'm saying like, yeah, my people. So I can see people using like, tuples with multiple elements. I'm asking, how often do you put this in cases where you serialize it? Is that really that common? But maybe I'm wrong.
I'm sure it comes up, and like the question is, are we, like, if this is only for hostile input, like, can we get away with making it like 50? I don't know.
Also, I was wrong. It goes up. Tuple goes up to 21.
Yeah. Keep in mind that whatever number you put in here, you should expect that the algorithmic complexity of O is O of n squared, where n is whatever upper limit you choose here.
You lost me there. Why is it O(n) squared?
Because your list, for instance, you have one list, then two lists, then three lists, and you add all of those together, and it's n squared. 1 + 2 + 3 + 4 is basically
for all the open generic basically visitors, like before. Yeah.
Oh, but the limit that you say total reasonable complexity is like that is at the root, right? So why would that be?
there's think of the complexity as a number of objects that you need to create, whereas how much work do you need to perform in order just to parse that object graph? You might be parsing more than O of 1 input to form a particular node in the object graph. So a 50 node graph could have 50 squared CPU time needed to create it.
I see. So you're basically saying it's not linear to the okay, yes.
Correct, it's quadratic.
Yeah. Sure.
And that's one of the reasons that we can't choose a very high limit here.
But this is not this is not selecting the limit. Like the limit should be in the property bag for the parser now.
Yeah.
Yes.
It's just the default you're choosing, right? So you could choose a reasonable number, and if the customer wants to dial it up, they can.
Yeah.
But I think the question is still, like, if it fails for enough people, like, you know, what do you think people will do? Right? They'll throw immediately in 100, and then, oh, it works, now ship that.
So what is the concern on parsing? Is it just like, I mean, parsing, my mind would go to parsing is naturally recursive. If you do things like have an array of arrays up to 50, then you're getting to like, am I blowing the stack limit? Like, is that what we're worried about with complexity, or
that's in large part, that's what it is, yeah.
Okay. Because then why would, I guess, because the way that the doc comment says is it seems to be tracking like number of type, like if you go to the doc comment on complexity, it's basically saying, oh God, I'm having to read this crap. Like it's a complexity of 8 to have like a dictionary of list of array. I would say, oh thank you.
Yeah.
I would say that complexity is actually 4.
Think of it as
because it's dictionary, list, int, array. So 5. 5 would be the complexity on that, because that's the natural level of recursion of that is 5. So I guess I'm trying to understand if it's the dictionary list.
It's not just depth. It's depth and breadth. If you were visiting everything here to see if it's in an allow list, for instance, you would need to do 8 units of work, because 8 units is what you need to fully deconstruct this thing.
But you just previously said that it's the n squared, and now you're trying to encompass the n squared in this number.
No, so it's n squared if you're trying to create the graph in the first place, or it's n squared if you're trying to do something that represents cumulative work across every node in the graph, but it's n to visit every node in the graph.
Okay.
Because basically you're saying there's dictionary of string comma list of int blah blah blah, but there's also a dictionary of, you know, t key t value, right? So you have to represent that twice basically.
Right.
Yes.
But the point that I think Jared's raising, which I don't know why I'm not letting him talk and I'm talking instead, is the max depth of the stack score of this is 5, which you get from right here.
The max depth will never exceed the complexity, but the complexity encompasses breadth, not just depth.
I guess why is breadth a concern then? I just don't understand why breadth is a concern to me. It's like it's extra work, but it's just
so you have tuple of list of list of list of list of list, comma, list of list of list of list of list, comma, and so on. That will never exceed depth 10, but the breadth times the depth will be in the thousands potentially. And it will make you do thousands upon thousands, maybe even millions of units of work, even though you never exceed depth 5 or 6.
Yeah, I think this goes back to the earlier point, right? It's not just about Stack Overflow, it's also about denial of service to force the server to do a lot of CPU bound work.
Mm-hmm.
So you're trying to limit effectively what you reasonably would be passed to you as a type name.
So go ahead.
I was saying in terms of security then, like you're talking about like allow lists and stuff. We were just talking earlier about like this making like the assembly name kind of simple. Like, would we not, I'm trying to think of like if we're thinking this from a security angle, I know from like a runtime perspective, like we really don't care about like versions of assemblies anymore. That doesn't really matter. Like .NET Core is just like, fuck it, all we care about is the simple name. From a security perspective, wouldn't you potentially care about the assembly name,
Yes.
the version? Is
Yep,
that why
absolutely.
we would just keep that thing down there, but make the other
that's-
name?
Allow it by default. Okay. I thought your default was to say you were prohibiting parsing it. It's like you say you care from a security perspective, but your default is don't read them.
So what I told our first party partners to do is when you have one of these objects, throw out the assembly name entirely and rely only on the type name itself. Because if you have an allow list, undoubtedly you do not have collisions. Like I don't see why your allow list would ever have collisions saying foo from assembly A and foo from assembly B. Like, no. Foo comes from assembly, foo assembly, or whatever. And that's what's in your allow list, and if you ever see a type name that says foo, return type of foo. That's the sample code that I gave them, and that's what they're running in production. The only time that they care about assembly names is if they're rewriting the assembly name in order to do things like change the version or change the public key token. Because binding redirects, for instance, don't allow changing the public key token. But they need to be able to do that.
At which point they're basically ignoring it.
Yeah. Because they changed their signing key from V1 to V2. I don't know why, but they did.
Yeah. People do that. It's a pain in the butt.
Didn't we change public key tokens for Silverlight?
Yeah.
It's a pain in the butt.
Okay. Just
Okay, so Jan advocated getting rid of total complexity. I see reasons why we would have it. Do we want to keep it, and do we like the name?
I would just call it complexity if we keep it. And frankly, I think we don't need the public API either.
I understand. So I understand the argument for why you'd want to have some complexity limit in the parser, but once the type name is back, I'm not, because the complexity is like, don't go past this. It's like if once you have the type name, you have a better understanding of like, how do I want to use that? Like complexity might mean something differently than for me than for you. Like I have the type name, I can walk the generics, I can make whatever measurement I want to measure for me.
Okay.
Well,
So-
then we do need to add
Yeah.
is name type
I was gonna say,
or is
the-
elemental type.
The problem is if we get rid of this number, we have to bring back the boolean.
I think we need to have it no matter what, in my opinion. Like you need to name the concept to refer to it.
I think that some people will ignore the docs and they will just try to learn it by running some code. So for example, they will, do type of dictionary of string of int.full name and pass it to the parser and check the complexity just to see what the value is.
Right, but so now they'll just have to hunt it by specifying options and keep lowering the number until it throws.
Yes, and our ultimate goal is to keep them secure, and they can put a very large number and become a victim of a denial of attack because somebody will pass them something that is very nested, and we will fail.
Yeah. If we have a max complexity, I do think it belongs on type name. Because of exactly what Adam said. It's a compelling argument. It's easier to check that way versus guess and check with the bool oracle.
We can also replace it from, Jan had the comment of it means we either have to store it or compute it, and if we're computing it, it shouldn't be a property. We can make it a method. So we don't store it, and we compute it when somebody asks.
But it's very cheap. So I have replaced the existing parser with the new parser, and at some point of time there was a perf difference, and I have profiled it, and the computing of it, which was always the thing, was never on the hot path. It was not in the profiles even because it was so quickly executing that it wasn't captured by a stacking profiler.
Yeah, I agree that it's not prohibitively expensive, but it's like some random number that people who care can compute the way they want, and most people don't care about at all. So,
but we are not forcing them to use this, and we are providing a reasonable default. So if you don't want to use it,
but this is so there are two different things: whether it should be on the type name object or and whether it should be enforced by the parser. I don't have a problem with enforcing some kind of limit on complexity by the parser. I'm just questioning like why it needs to be API on the type name. Right, because if you shouldn't need to store it on the type name in order to enforce the limit during the parsing.
I mean, I think it makes how to use the limit way more clear, right? Like if you're setting this thing and it's not easy to like check like what is it for this type without like, you know, doing a binary search on the limit and waiting for this API to throw or something. Like, you know what I mean? You gotta be able to measure it.
It's kind of similar with all other similar checks. We have like for regexes we have like maximum time, right? How do you choose your maximum time, right? It's kind of this exact same problem. You can kind of, you know, do some perf testing, or you do some testing, or you can kind of do some math on paper to see like what limit might be okay for you.
You're not simplifying anything if you keep the max complexity, but then remove it from the type name, in my opinion. Like you're just making it more inscrutable. Like what that max is. Like,
you know, like my take on this would be like the maximum on the parser should be just to prevent the parser from stack overflowing and nothing else. Like the kind of the enforcement of like the work required to build the types, you know, it should be kind of a problem for the like the opinionated secure wrappers of this to deal with, right?
like I might agree with you if we were in a world where we could like change how we calculated the complexity, and this was some like general knob, like you know, the regex should take less than a second. You know what I mean? If it was like, yeah, just give me like a percentage from 0 to 100, but like complexity has to have a very specific meaning, or we're gonna break people. And at that point, like, why not just tell people what it is? Like we're calculating it anyway. It makes the API easier to use.
Well, if you want to make it like, so you know, like another take on this would be if you want to just prevent the stack overflow, the parser from stack overflowing, we can just use the, you know, the built-in stack overflow protection thing, and you know, just keep parsing as long as the stack is sufficient. And you know, fail gracefully if it's like too big. That and you know, like, and then you know, like once we return the parse name successfully, let people check the complexity of that thing any way they want. Right?
Yeah, it looks like Levi dropped, but he was, I mean, Jared had asked the question of why is complexity breadth and not depth, and Levi wanted it to be breadth. So if we're back to just talking about Stack Overflow, that's just depth. And
Yep.
Right, there are like multiple different kinds of complexity, and you know,
right.
Right. So that's kind of the problem, that we are basically creating opinionated API here. That
yeah, but
kind of...
the important thing is that we are creating these opinionated APIs because there were incidents that costed us a lot of money, and
Yeah.
based on Levi's experience, who took part in solving them, this API was created. So it's not
So
like...
I'm not saying that the secure parser should, you know, ignore the complexity. I absolutely agree with you that, you know, the secure binder should worry about the complexity. I'm just saying that, you know, maybe the place to worry about the complexity is the secure binder and not this low-level API.
Yeah, but so my only argument is that people might want to, you know, find what is the perfect total complexity for them. And they, for example, they can be injecting, you know, a singleton of a serializer in their dependency injection, and they will just add one line that, you know, they will do input.getType, pass it here, and log the total complexity, and run the whole thing, and just copy the value to the setting.
Right, so the secure binder can have API to compute the complexity using the algorithm that the secure binder uses, right, to handle that scenario.
And it returns a type name, which has the total complexity that you can log, right? So you don't have to do a binary search, so it doesn't just like throw or something.
No, I am arguing for the algorithm to compute the complexity to not be in this API at all. You just
So like it's
make it consent for the upper levels.
so is it like an out parameter, or are we going to put this in like
No.
a result type?
No, it wouldn't be here at all. The only complexity that I would keep here maybe would be the kind of the, maybe the complexity isn't a good name, but basically like in the parse options, you have something that controls the depth of the stack that the parser can use.
Well, and this gets back to the whole conversation we had with Jared and Levi. So maybe we have to wait for quorum so like everyone can participate.
Yeah, I'm trying to just take simple notes that we can pack up for the needs work, aka we ran out of time. I'm super objecting to returning a span here. It might be read-only memory, but it should not be read-only span.
I'm fine with read-only memory. I just didn't want to create a copy of an array for the
Right.
sake of returning an array that is mutable.
Right, so I'll just take that note, and if it comes back next time, then we'll have the debate then. Okay,
All right.
and we don't like the word strict in strict validation, but no new name was provided. Okay, so I think maybe come back. It seems like we're going to need to name is elemental type, especially if we cut the complexity property. And
yeah, so people don't
that'll
have
be
to check the other 5 properties.
Right, so that'll be a bike shed for next time. And then strict validation. Because to me, strict means like the spec says do this and only this, and that's not what it means. The default is do what the spec says, and then strict is like we have extra rules, and so somebody needs to come up with a thing that describes take our opinionated advice, and strict is not that word.
So
I'm
not a native speaker. I'm not going to argue with you.
Yeah.
It was just my proposal.
Yeah, for the validation, I would actually create flags or whatever for the things that the validation for the extra validation, so that there's not kind of some kind of this like ambiguous opinionated thing, but it's like, yes, I just want to do this exact strict validation, like this extra additional validation, and you know what you are thinking,
Right.
Yep, I was thinking about that, and the problem is that it can be a lot of properties, let's say 8 or 10 Boolean properties. So would it be acceptable if I introduce an enum that would be a flag and we
I was
put
gonna say,
for all of them?
Are you less than 32 of them? If so, flags enum is your friend.
You can make it a long enum. Get even more Boolean options.
And once we have that list, we can also discuss whether each of them makes sense for this parser. Like the one I don't like is like just rejecting particular characters. That's very ad hoc. That's something that can be done by the hardened parser that wraps this.
Yeah, but with that we want to make it really accessible to the end users so they can.
We said that we don't like that. The hardened parsers built out of this will be or binders will be built by us, right? It's like the same argument as like we had earlier, whether everybody needs to copy this piece of code, right?
Yeah, you're right. Sorry.
Yeah. All right. So, because we didn't finish, bouncing it back as needs work, and then after I hit publish on the notes, I'll just bounce it back to approve, so you don't have to worry about it, Adam. Sorry, I'll bounce it back to ready for review. But it needs to say needs work before I hit publish on the meeting notes.
Thank you, and talk to you next Tuesday, I guess.
Yep.
Right.
Type names will be back. Thank you.
Yep. All right, and we don't have any Thursdays scheduled still, right, Emo?
We do not. We can. I mean, this week is probably bad due to MVP Summit, but
I like how now it says last week was at 11 because time zones. All right, so we don't have anything on this Thursday. Thursdays maybe coming back at some point because we have a list. And but otherwise, we'll see anybody who wants to continue this discussion next Tuesday at 10 a.m. Redmond time, which is, as of this week, an hour sooner than it used to be. Yeah, there we go. And cool. So see y'all then. And if not, then enjoy your sanity. And auf Wiedersehen.
bye-bye.